Pleasure to be here today to see new colors of my slides. It's going to be interesting. But in any case, to convey some directional information here. For those who have seen one or two talks from Intel, you know what the next slide is going to be. And all of this is about making sure that we all understand that the future is something we have understanding of what we want to do, and it doesn't always work out the way we expect. But and so the directional information here is directional. Anyway, so we were asked to give a bit of an update of the future of x86. Well, to us, that's the Intel architecture. And before we get into that, I wanted to lay the context of it because, 10 years ago, we would have been speaking only of the processor and the software that goes with it to do HPC. But clearly things have changed over those 10 years with respect to the overall commitment and investment in high performance computing beyond, pardon the pun, the core activities. Clearly we have engaged for many years now in the area of terascale on a processor research. And you may recall back in the day when we were demonstrating the teraflop capability of an 80-core test processor as a pathfinder for how to deal with a mini-core kind of product. And that research still continues with respect to how to drive performance and performance per watt capabilities into our standard high volume capabilities. Clearly the manufacturing process continues to go strong. We'll see a slide on this as we continue to see our transistor budget continuing to double roughly every 2 years. And then performance and performance per watt, we clearly, very tied to this, very much interested in that. But in the high volume server capability, and that's highly, it's almost a horizontal across much of this as we bring power capability and power management much closer to the processor over time, and the ability to be much more flexible with power consumption, and if you will, program guided power consumption. And of course the platform building blocks, we do a lot with respect to making sure that as our products are ready, that they're ready to go out the door with our fellow travelers, and the engagements to do that is a significant level of investment in validation, but also not at the server level but at the cluster level. We have a significant investment in the ability to assure that the full stack of solution is ready to go when the product is going to go GA, and that's a major investment of us. We maintain an industry standard clustering environment in order to drive rapid adoption of the technologies. So again, as we're releasing x86 processors, or our IA processors, on almost a yearly cadence, it takes a lot of work to assure that they can go to market seamlessly and ramp as quickly as possible. And part of that is having a clear understanding of what it takes in order to assure that the rest of the ecosystem is ready to go. And that is a major investment and focus point for us. And of course, one of the earlier things that we had invested in is the software around our total solution, and that is continuing to move forward as well. Some say that the exascale environment is leading to new software environments, and while that may be true, part of what we're looking at as well is making sure that the investments in software are able to be retained over time onto future architectures. And that takes a major investment in software capability to map existing applications onto new architectures. Complementing the processor is in the interconnect technology. If we had more time, we could get into everything about what we're doing in Fabric. But to summarize, you may have seen that last year was certainly a year different for us as we acquired the Aries Fabric capability out of Cray, and also the QLogic TrueScale Fabric technologies out of QLogic, and have combined that those two teams to come up with a world-class leading fabric product capability going into next generation fabric, and we'll be showing a little bit of what that's coming up to. But clearly that's becoming an area that is incredibly important as it is a feeding mechanism to why it matters as to what the processor is capable of doing. We maintain our expertise in the area of being able to map the technologies to real user world problems, and we maintain for the ability to test applications a variety of offerings in order to assure that that end users can see how the technology plays out on a cadence of the new product coming to bear. So early access to our technology is something that we try to make as available as possible in order to, again, manage to get product adopted as quickly as possible. What's motivating all of this is the fact that the bottom line of this particular slide is that the HPC application space, or if you will, the market segment itself and its breadth and its depth is expanding. I'm not saying anything about the volume per se. We leave it to IDC to help measure what's happening and predicting what happens in volume. But clearly, in the traditional spaces, we see continued R&D to go further with the technology than had been before. So it's not like we have a particular vertical that is sitting with a capability and they're fine, they've matured, that's all they're going to go into. It's continuing to deepen there. And at the same time, we're seeing that the HPC technology is being utilized in a broader application space. And as that has gained traction over time, we also see it deepening there as well. And so we could get into what's happening, for example, in digital content creation with respect to what used to be used just a few years ago and what is needed now in order to maintain and grow their particular business ventures. But we also see an area of increased utilization of high performance computing in security. We've always had security around HPC, but with respect to it being used for security is definitely a growth environment. To match those particular areas and kind of to the theme of what we were asked to give an update on is IA futures. Last year we introduced the Xeon Phi coprocessor to complement the Xeon processor. And as far as the future is concerned, the complementary aspect of these two products will continue. The parallel lines of their optimization points are indeed going to remain parallel as far as we can see. And what this means is that we maintain the workhorse aspect of the Xeon processor while investing significantly in the Xeon Phi coprocessor to deal with those applications that have both a high vectorization capability, high floating point necessity, and also high integer capability, as well as high thread count type situations. The cross-section of threading and vectorization is the sweet spot of that product. And we find that having a complementary approach to that is the optimal way to go, and we'll be continuing to see that going forward. The programming environment, as I mentioned earlier, is incredibly important to us to make sure that we do indeed maintain the investments of the end users as to what they've done already and what they are looking to do. And the guidance we're giving is that the applications today will have the environments to continue forward with those applications while we richen what you could do with an API environment and programming language environment. We're not requiring the adoption of that technology or the reformulating or refactoring of an application in order to make use of our latest generation technology. Sure, things will move evolutionary, but we don't have a revolutionary disconnect for going from one generation to another. And that also speaks to applications development for both Xeon Phi and Xeon processors. The thing we want to get across is that the optimization points weren't about the instruction set architecture. It was about the natural parallelism and the extraction of that parallelism within an application. And indeed, we're able to approach both product lines with the same software tools, same debugging tools, same performance analysis tools, and are able to see that the applications will run in both environments. To get it to run well in both environments is pretty much the same level of optimizations across. We want to see vectorization, we want to see threading. While we're challenged as a community to actually do both of those, we're finding that there's quite a bit of investment that has yet to make complete use of the performance capabilities that the Xeon processor has been offering for years. And so with respect to everything continuing moving forward, as we have made the Xeon Phi coprocessor available for those applications that are ready to have that level of parallelism extracted, and the code has been optimized to be able to express that parallelism, we also find that as we approach that, applications run extremely much better on the Xeon processor as well. We've seen many ratios of this is what runs on the Xeon Phi coprocessor versus the Xeon before, but when we take that code and put it back on after extracting the parallelism, again without having to change the fundamental programming methodologies, sure we may have data structures reformulated and so on in order to be able to feed the pipes, but once we've done that as well, we've also seen the features that we've had in Xeon for quite some time and that we continue to enhance over time will have much greater performance as well. So the ratio between the two on a best in best case isn't going to be that 100-fold, but it isn't definitely showing the value propositions of being and having both products out there for us. We just saw a talk about microservers as well. We also have a full line of microserver capability developed at Intel in order to pursue integer-rich, transaction-rich environments and full-up capability. And we've had a good track record of seeing the product taken up by our fellow travelers, our OEMs, in order to bring that to market. And hopefully we'll see more of that in conversations throughout today or in demonstrations. But clearly, with respect to advocating that performance per watt is important, we're all there, and we're tuning to each of those usage cases. But what we want to make sure of is that we don't end up with a one-size-fits-all in all cases. And so again, it's a full portfolio of activity that is supported by a common architecture. That common architecture, this is a performance slide of what we had going from our prior generation of Westmere to Sandy Bridge last year, just as a reminder that indeed, when it comes to performance and performance per watt, we're not doing just performance per watt. We're also doing performance. On a socket for socket basis, year over year, we continue to see the performance gains moving forward. That was Sandy Bridge. We have Ivy Bridge coming up. And then after Ivy Bridge, we have next generation processor, which has the AVX2 in it. And we'll be seeing the doubling of floating point performance on a per core basis with AVX2. And just a few generations later, we have AVX3 coming along, which will also, again, double that level of performance. So future of x86 or Intel architecture from Intel is we have terascale processors now in the form of the Xeon Phi coprocessor, and we will have terascale processors on the Xeon side as well in the not too distant future. And with respect to the overall technologies moving forward on our tick-tock cadence, an annual product introduction. We are at the Sandy Bridge. We're on the cusp of seeing Ivy Bridge going general availability. Next generation is Haswell. That's where we had the AVX2 coming along. After Haswell is the next generation that would be a shrink of that. And beyond that is where we see additional enhancements going forward. So with respect to future, it's looking very strong in capabilities as enabled by all of that ecosystem that I had mentioned earlier. But the future is not just computing, it's also computing and communicating. And this is where that investment in fabric technology, as it merges with our investment in computing technology, come together. And we see an integrated fabric and computing complex being introduced in the not too distant future. And we're out of time on this, but perhaps later we'll be seeing some discussion around disruptive technologies, and we believe this is indeed the merging for performance from performance per watt is driving to this particular disruptive technology capability. Thank you very much.
Thank you.